Next one is reaction of alcohols with the SOCl. SOCl2 means it is thionyl chloride. And reaction of alcohol with the thionyl chloride, it produces alkyl chlorides, and that method, that process we will call as Darjan's process or Darjan's method. Okay, what is the reaction? Alcohol, general formula ROH, reacted with thionyl chloride SOCl2. This is thionyl chloride. Sulfuryl chloride means SO2Cl2. Thionyl chloride means SOCl2. And here ROH and SOCl2, and it produces, OH will be replaced, substituted by the chlorine. Then you will get the OH will be removed and chlorine will be added. RCl, alkyl, what it is? Alkyl chloride. Along with this, OH is removed, one H and one HCl will be removed as HCl. SO, another O is there, so that's why SO and O and combined gives SO. Yeah, and now this SO2 is a gas and HCl also gas. So that's why this method is very convenient method to prepare the alkyl chlorides. Why? Why? Because in the reaction mixture, byproducts are along with the alkyl chloride, SOCl2 and HCl also generated. And SO2 and HCl both are gases, so they escape from the reaction mixture. You will get the pure alkyl chloride. So that's why no further purification of this compound required. So that's why it is very convenient method to prepare the alkyl chlorides. Simple example, this is general reaction. If I take example, suppose if I take alcohol, ethanol, I will take ethanol, react with SOCl2, then you will get the compound is ethyl chloride, Cl plus SO2, and the next one is HCl. Yeah, so this is the what it is, Darjan's method. Next one is preparation methods of aryl halides. Till now what we have discussed, that is preparation methods of alkyl halides. Now we will start the preparation methods of aryl halides. The first one is by electrophilic substitution reaction. You have already studied this reaction in the first year. Chlorination on or halogenation on the benzene ring. Clear? So first one is by electrophilic substitution reaction. So what we will take here, I will take the benzene and treat it with the halogen atom. You can take X2, mainly X is equal to what here? Chloride and bromine. Chlorine and bromine in presence of Lewis acids like AlCl3 or FeCl3, or sometimes what they will give, iron. Why? Because iron and react with, suppose chlorine if I take, you will get the FeX3, means FeCl3. Yeah? Then what the compound you will get? You will get the compound is, here X plus what it is, HCl. Yeah? So this we will call as halogenation reaction, and it is electrophilic substitution reaction, and we will prepare aryl halides. Aryl halides. So mechanism is there. You have already studied the mechanism in the first year. I will not discuss it again. Suppose if I take, example, benzene treated with the chlorine in presence of AlCl3, then you will get the compound is chlorobenzene plus HCl. If I take here bromine, then what you will get? You will get the compound is AlCl3, and you will get the, suppose sometimes they will give Fe also here. Fe means what is the catalyst you will get here? Fe reacted with the bromine, you will get the FeBr3, like same previous. Okay. Then what the compound you will get? You will get the aryl bromide or bromobenzene, then you will get the HBr. And Next one is, if I want to prepare iodobenzene, then what I have to do? I have to use here oxidizing agents. I have to use which one? Oxidizing agents. You already know. If I take this one, Fe, suppose I3 or FeBr3, halogen here, because iodine is, if you take, if I take here catalyst, suppose Fe, then what I will get the compound here? Iodine plus what it is? Hi. You know that previously we have discussed. Hi is a powerful reducing agent. So it reduces iodobenzene into benzene plus iodine. So that's why this reaction becomes reversible. So you have to use here oxidizing agents. We have already discussed, like HNO3 and HiO3 or HZO, etc. Yeah, this is how to prepare the aryl halides from the electrophilic substitution reaction on benzene with the halogens. Second method for the preparation of aryl halides is by Sandmeyer reaction. Very important reaction. What is the Sandmeyer reaction? The decomposition of benzene disonium chlorides. In presence of cuprous halides. Dissolved in respective halogen acids and produces aryl halides. Okay? See what is that one? Benzene disonium halides. This is benzene. If it is there N2 diazo, we will call, and plus and X minus. This we will call as benzene disonium salt. Benzene disonium halides. Clear? And it is treated with cuprous halides. Cu2X2, or you can write here CuX, which is dissolved in respective halogen acid HX and produces, and here aryl halides plus N2 gas, and this reaction we will call as Sandmeyer reaction. And how to prepare this benzene disonium chloride? This we will study in the amines chapter, but I will simply say how to prepare this benzene disonium halides. Clear? Take the aniline aromatic primary amines treated with sodium nitrite and HX at 0 to 5 degrees centigrade. Then you will get the compound is benzene disonium halides. This is the compound. How to do it? Very important. This is, we will discuss again this how to conversion of aniline into benzene disonium chloride in the amines chapter. Yeah. So remember that one. So this reaction we will call as a Sandmeyer reaction. Suppose I will write the examples. And if I take the compound here N2 plus and Cl minus, I will write. Yeah. Then I will put here Cu2, Cl2 and HCl. Then what the compound you will get here? You will get the compound is chlorobenzene. Yeah. In the same way, if I wanted to prepare here bromobenzene, then I will take the benzene disonium bromide here and then treated this one with the Cu2, Br2 and HBr. Then you will get the compound is N bromobenzene plus N2. If you wanted to prepare here iodobenzene, you need not to use cuprous halides here. Benzene disonium chloride, and it is, suppose benzene disonium chloride I will take. Benzene disonium chloride. Then what you will get here, you see, minus, and you will get the compound. Simply treat this one with the potassium iodide. You know, I minus is a powerful nucleophile and it replaces the N2 group here, and you will get iodine plus and N2 plus KCl. Yeah, and this reaction, actually this reaction we cannot consider as a Sand-Meyer reaction. Why? We are not using here any cuprous halides in this reaction. So that's why. But we are preparing this one from the benzene disonium salts. Okay? If you wanted to prepare benzene disonium fluoride, and we cannot prepare benzene disonium, we cannot prepare here fluorobenzene. If you wanted to prepare, we cannot prepare by using this method. Another method that is there, that we will call as Boltzmann reaction. How to prepare this one? Same, we will take in this one benzene disonium chloride. I will take that benzene disonium chloride. It is treated with the fluoroboric acid, BF4. Then what happened? And H and Cl will be removed as a HCl minus HCl. Then you will get the N2 plus BF4 minus benzene disonium fluoroborate. Now heat this one. If you heat this, then what the compound you will get is fluorine will be added here, N2 will be removed, and another one what is there? Boron trifluoride. This is Boltzmann reaction. How to prepare this fluorobenzene means by using this reaction. And very important here, sometimes what they will give the compound here benzene disonium halide, and suppose chloride they will give here benzene disonium chloride, and now and Cu2 Br2, and they will give here HCl. Now you may get the confusion which one will be added on the bromine, either bromine or either bromine or chlorine, because here you see CuCl2 means HCl, Cu2Br2 means HBr. If I take Cu2Br2, it is dissolved in the HCl. Then remember always the halogen which is bonded to the copper will be added on the benzene ring. So which one is bonded to the copper here? Bromine. So that's why you will get the compound is, and here bromobenzene plus N2 plus Cu2 Cl2 you will get. This is the reaction. This is the Sand-Meyer reaction. Table I have written clearly. And benzene disonium chloride and treated with the Cu2Cl2 and HCl, chlorobenzene, Cr2Br2 HBr, bromobenzene, Cu2Br2 HCl. But I said which one will be added on the benzene ring? Which is attached to the, which halide attached to the copper, that only added on the benzene ring. And you know, for the preparation of iodobenzene, we need not to take the any copper halides, because you know iodide ion is a powerful nucleophile and it replaces nitrogen. So that's why you will get the iodobenzene. If you wanted to prepare your fluorobenzene, and I already mentioned the reaction, Boltzmann reaction. So you will get the fluorobenzene. This is about the Sand-Meyer reaction. Up to here we will call this is Sand-Meyer reaction. This is Sand-Meyer reaction. These two are not Sand-Meyer. You know this reaction, and Boltzmann reaction, and this is a potassium iodide, and separate reaction. This is